In this video, we will talk about how to determine the test that we are looking at given the scenario. So whenever you're given a problem, the first important thing to do is figure out what type of test you're even looking at. I recommend asking yourself the following questions to help you decide. So the first thing I would think about is, do you have proportions or do you have means and averages? Proportions could always be written as percentages. Sometimes they'll give you like the number of people out of a total. So I might say in my class of 30 kids, I had 4 of them wearing glasses. So 4 out of 30 would be my proportion, which then I can turn into a percentage. If they're giving you averages or means, they will literally have to use the word average or mean. After that, I would ask yourself whether your data came from 1 sample or 2 samples. You could have either option for both proportions and for averages. And then the third thing I would ask yourself is, are you making a confidence interval or are you running a hypothesis test? The last thing that you want to do is sit here and go through the entire phantoms process when all you needed to do was find a confidence interval. So your options that we have are a 1 sample proportion, so that would be just 1% from a certain group. You could have 2 sample proportions, so 2 groups and percentages for each of them. You could have a 1 sample mean, so 1 group and they only gave you that average for that 1 group. You could have 2 sample means, or you could have a 2 sample paired means. Oftentimes these two get confused because they look so similar. With both of these, I would always ask yourself whether the data has something in common. If we saw in class, we talked about how in PE we might be doing like a push-up test, and I maybe did 30 push-ups the first time and 32 the second time. Both of these numbers have something in common. They relate to me. So if I put Miss Peck here and she does 20 push-ups and 24 push-ups, these numbers both go with Miss Peck. I can't just randomly switch the 32 and the 24 because then I'm switching the people. So always ask yourself whether you think that data is paired. If it's paired, you're running a 2 sample paired test. If it's not, it's a 2 sample independent test. So our first example says a national survey conducted in 2018 determined that 135 out of 300 U.S. adults had at least 1 tattoo. Another survey conducted in Canada found that 145 out of 350 Canadian adults had at least 1 tattoo. Is there evidence that U.S. adults are more likely to have at least 1 tattoo compared to Canadian adults? So the first thing we need to determine is, am I looking at proportions or means? I don't see anything in here talking about averages. In fact, they're telling me 135 out of 300, which is a proportion. Was it 1 or 2 samples? Because they gave me 2 proportions here, one of those proportions for U.S. adults and the other proportion for Canadian, this would be a 2 sample. Because I was dealing with proportions, I know that I should be using a z-score. Z-scores in normal models always correspond to proportions. For means, we will use t's. Degrees of freedom is only for a t-distribution, so this is not applicable. I don't need degrees of freedom when it comes to the normal model, and I'm using a z-score. Go ahead and take a minute to try example 2. Alright, example 3 says a boot company would like to see if a new waterproof spray is more effective than an old spray. 50 volunteers agree to participate in the experiment. Participants are randomly told whether to spray the new spray on their left or right boot. After 50 days, participants will record the average level of water damage on their boots. Does the evidence suggest that the new spray is more effective than the old? So I need to think first if I'm looking at proportions or means. They didn't really give me a proportion. Instead, it looks like they were talking about the average level of water damage. So this would be a mean. Was it 1 sample or 2 samples? This is kind of a tricky one because it looks like we only have these 50 volunteers, but each volunteer was doing 2 things. They were spraying the new spray on either their left or their right. So this is actually a 2 sample paired test. The pairing came from each person. They either had their left or their right boot, one sprayed with the new, one sprayed with the old. The pairing again comes down to that participant. Z or T, because I'm looking at the mean, this would be a T. And although it does look like we have two samples, because it was paired together, I can actually calculate my degrees of freedom similarly to how we did on example 2. I'm going to take my sample size and subtract 1. So 50 minus 1 is 49. Remember that anytime you have a paired test, you can always calculate that degrees of freedom. The only time that we won't be able to calculate our degrees of freedom is if I have just a regular 2-sample t-test. All right, let's take a look at example 4. Example 4 says a man who moves to a new city sees that there are 2 routes he could take to work. A neighbor who has lived there a long time tells him route A will average 5 minutes faster than route B. The man decides to experiment. Each day he flips a coin to determine which way to go, driving each route 20 days. He found that route A takes an average of 40 minutes with a standard deviation of 3, and route B takes an average of 43 minutes with a standard deviation of 2 minutes. Histograms of travel times for the routes are roughly symmetric and show no outliers. Proportions or means. Because they're talking about averages and standard deviations, I'm definitely looking at means. 1 or 2 samples. They were talking about 2 routes to get to work, so I'm thinking definitely 2 samples. And this is a 2-sample t-test where the data is independent. They are not paired this time. Route A and Route B have absolutely nothing to do with each other, so they are independent. Again, means I'm always using a t-score. And this one I think is kind of tricky. The degrees of freedom I would have to find on my calculator. Remember that whenever we're doing a 2-sample t-test that's independent, so not paired, if it's 2 samples, I always have to use my calculator to find those degrees of freedom.